So this example states, a clothing company wants to export their line of clothing for women to a new country. Their current clothing sizes are based on the assumption the average height of a woman is 162 centimeters. To determine whether they can simply ship the clothes to the new country, they selected 12 women at random in the target country and determined the mean height to be 155.2 centimeters with a standard deviation of 6.2 centimeters. Based on alpha equal 0.01, should they proceed to enter the new market? Should they adjust their clothing line? So starting off with stating our hypotheses, we have H0 and H1. Now, in this question, there's a couple ways we can look at this, but the way I interpret this is that the mean either equals 162 or the mean does not equal 162. There's no indication of direction in this case, but you could also say, well, you think that the mean is less than 162 based on the current findings, right? But I'm going to approach this as saying, well, the mean is either 162 or is not 162. Next, we're going to put the critical values together. And once again, from this, you can see this is a two-tail picture. All right, so we'll put our two tails together here. Oh, and I forgot to mention, even before we started this, our value for the sample size is 12, which implies that we are going to use a t-score because it's less than 30, right? So t-score. So we're going to use the t-table to determine our critical values. Now, alpha is 0.01, so let's just state that. Alpha, 0.01, degrees of freedom is 12 minus 1, which is 11. So we're going to look at the two-tail row, the 0.01 alpha column, and the row with 11 degrees of freedom in our table for hypothesis testing, the t-table. So let's keep that in mind. And when we jump to the t-table, we're going to be using the two-tail row, alpha 0.01, and degrees of freedom was 12 minus 1, which is 11. And so the magic value, in this case, or the critical value, is 3.106. So the critical values are going to be 3.106 and negative 3.106. Third, we're going to do the t-score, which is the mean, sample mean minus the population mean, all over the standard deviation divided by square root of sample size. And that gives us 155.2 minus 162, all divided by the standard deviation of 6.2 divided by square root of 12. This will then give us a final value of negative 3.799337255. And we will round that to three decimals, and that's approximately negative 3.799. And this time it's negative. So we're going to plot that in our graph over here, or our curve, and it turns out that our test value is there, so we are in the rejection region, right? So we're going to reject our null hypothesis. So let me just put this here for reject our null hypothesis. And once again, let's just revisit that. We are going to reject this statement, and we're not going to reject this statement. In other words, we're going to assume this to be true unless we get other evidence. So we can say the mean is not equal to 162 centimeters. All right, so putting that together as a statement, we would have the following. Our sample data indicates the population mean height for women in the target country is significantly different than 162 centimeters. With that said, you should be able to handle the homework for this section. Just make sure that you systematically follow the steps and make sure you understand what it is that your findings are. If you have any questions, make sure to reach out. Have fun.